Welcome back, everyone. This is section 6.6, variation. In this section, we're going to be discussing direct variation and some of the other variations of that, as well as inverse variation, which will be a separate video. So the first thing we're going to talk about is direct variation. This is an Algebra 1 concept. So direct variation is y equals k times x, where k is the constant of variation. If you notice, y equals kx is very similar to y equals mx plus b. The only difference is the b, or the y-intercept, is 0. So if you were to graph this equation, it would look something like this, where as the x increases, the y also increases. Okay, unless it's negative. But you'll notice it goes through the origin, and that's a sign of direct variation. There's no y-intercept like it would be with something else that's in slope-intercept form. Okay, so let's see an example so you can get the idea of how it works. So y equals 2.50x is an equation relating the number of gallons of gasoline purchased to the price. What is x? What is y? So x in all of our equations is the input. So as you input something, it gets affected by the equation, and y is the output. But in the problem, how does it relate to the different types of units? So we have gallons of gasoline as one of the units, and then the price. So what's affected? Is the price, does the amount of dollars you put in affect how many gallons you get out? No, that's not the case. The number of gallons you choose, which is the input, will determine how much you pay. So the price. Now, as you're filling up your gas tank, the more gallons you put in, how is the price, or y, affected? So as x increases, y also increases. And as x decreases, y decreases. So if you put in less gallons, fewer gallons, then you'll pay fewer dollars for that. So what is $2.50? This would be our constant of variation. So in this particular case, $2.50, you should recognize that as the price per gallon. Okay, you'll notice how it relates the two different inputs and outputs into one constant, price per gallon. So if our input was gallons and our output is price, the constant of variation relates the two. So the gallons is affected by the constant of variation. Let's jump into our second example. Alyssa reviewed her paycheck and saw that she made $174.50 for 15 hours of work. If she works for 20 hours next week, how much money will she earn? So this is a problem that can be put into a direct variation form, y equals kx. So one thing that we know is we have hours and we have dollars. Just like we did before, the output is going to be dollars. So $174 is the output, okay? The amount of work you put in directly affects direct variation, the amount of money that you receive. Now, the one thing we don't know is we do not know what is the constant of variation. How much does she make per hour? But we can find that easily by dividing both sides by 15. Once we put 15 in for x, 174 in for y. And that leads us to it's going to be around $11, I think. So we do 174.50 divided by 15. That gives us k equals 11.63. Let's put this into the context of the problem. What does this mean? Well, we divided dollars by hours. So this is dollars per hour. So if she works for 20 hours next week, how much money will she earn? Well, we could put it back into our equation, but now we know that the constant of variation. So now we're just going to put the new value in for what's known. Oops, 63, sorry. So we input 20 in for x, 11.63 times 20, and that's going to tell us how much money she will earn, which is $232.67. Here's a problem that's not kind of a real world example, just using variables. It's the very same process. If y varies directly with x and y equals 12 when x equals 8, then what will y equal when x equals 20? Y equals kx. This is direct variation because it says it varies directly. So y equals 12 when x equals 8. We don't know k, so we're going to solve for k. So we divide by 8, and we get 1.5 equals k, or if you want, you can say k equals 3 over 2. Either way, we're going to put that back into our equation, so now we know that it's 1.5 times x, and we know that x is 20. We're going to ask for when x is 20, and that equals y. If it said y equals 20, you would do the same thing. You would just plug in 20 for y, and then you would solve for x, which is a similar process, but hopefully you guys can know the difference of when you use that case. So you do 1.5 times 20, and that should give us 30. So that would be our answer. So now we have direct variation as a power. So y varies directly as the nth power of x if there exists a real number k such that y equals k times x. Oops, to the n, not squared. So if it says it's to the nth power, then that nth power is going to be there. So very similar process. The only difference is this has got an exponent. Okay, but we're going to approach things exactly the same way as before. The distance a body falls from rest varies directly as the square of the time it falls. If a skydiver falls 64 feet in 2 seconds, how far will she fall in 8 seconds? So let's break down the information here. So we say distance a body falls varies directly as the square. Okay, so d equals, the distance equals directly. So direct variation, we're going to have a constant k as the square of time. Let me change the color here, as the square of the time. So that means we're going to square time. So as you can see here, anytime you see some sort of exponent or square or cube or something like that, you're going to have an exponent, which you need to account for in this type of equation. Now let's input what we know. Well, we know the distance right away. We know the distance is 64 feet, so let's go ahead and put 64 in for d, equals k, that's the thing we do not know, times time squared. Well, we know the time is given as 2 seconds, so 2 squared. Order of operations first, square the 2, we get 4. I'm going to put the k second, 64. Divide both sides by 4. I get 16 equals k. Now that we have that, we're ready to proceed so we can find out how much she falls in 8 seconds. That's what she's asking. It's not asking for the constant of variation. It's just asking for another example. But intuitively, we are going to find the constant of variation. So what we're going to do now is we're trying to find how far. So we're looking for the distance. Okay, we already found k in the previous problem. Forgot to mention that. So 16 equals k times t squared. We know that we're looking for 8 seconds. Make sure you follow order of operations here. You're gonna cube or square 8. Multiply that by 16. I think we should get 1,024. Let me just double check that. 64 times 16. Yep, we get distance equals 1,024 feet. Those are the units. And that's how you do direct variation and direct variation as a power. Stay tuned for the next video where we talk about inverse variation.